Today we're going to be going over factoring quadratic and polynomial expressions. Now these are worth 15 points on your average SAT, so definitely one worth knowing. Our approach to these is going to be to identify factoring quadratic and polynomial expressions questions. We're going to break down the question, we're going to build a formula to solve them, and then lastly we're going to do a practice question together. So how do you identify these? Well, these questions will give you a quadratic or a polynomial, and they'll ask you to find the roots or the answer. Now you can either factor or factor by grouping. We'll look at factoring in our example, and we'll go over a factor by grouping question here, and so we can make sure we know how to do it both ways. Another thing that I'm going to mention is for this concept, you want to be using Desmos almost on every single question. That's because it's going to get you the answer quicker, probably half the time as doing it the old-fashioned way, and your answers are probably going to be right more often. Now, I know a lot of students like to check their answers, so a great strategy on these would be to use factoring or factor by grouping, and then quickly plug into Desmos to see if your answer is correct. So let's do a quick factor by grouping problem, and then we'll move on to our example with factoring. So factor by grouping is going to be most useful when you have a polynomial with a number in front of our x squared. So if we had like 2x squared plus 5x minus 12, and we want to find our roots, we're going to start by multiplying the number in front of our x squared and our constant. So that's 2 times negative 12. It's going to equal negative 24. Now what we're looking for two numbers that will equal negative 24 when multiplied by each other and add to positive 5. And so for me, I'm thinking that these numbers are probably going to be positive 8x and negative 3x. And so I'm going to rewrite our equation as 2x squared plus 8x minus 3x minus 12. Now, as you can see, we actually haven't changed our top equation at all. If we would simplify it, it would give us the exact same equation, but we're going to be able to group common terms here, as you'll see in a second, which will help us get our answer a little easier. First thing I'm going to do is with these first two terms, I'm going to find a common term. And so the biggest common term I think I can pull out of both of these is 2x. So 2x times x plus 4. And then for these second two terms, I think I can pull out a negative 3. So negative 3 times x plus 4. Now you'll know you did factoring by grouping correctly if two of the terms are the same. And so we still have 2x plus 4 here. And so we can combine the 2x and the minus 3. So we go over here and we have 2x minus 3. And then both of them have this x plus 4. And so x plus 4 is our second term. Now solving from here should be a lot easier. So we can have x plus 4 equals 0. So one of our roots is going to be negative 4. And then we can have 2x minus 3 equals 0, which means our second root is going to be x equals 3 halves. So this is a lot easier way of getting factors if you have a 2 in front of your x squared or 3 or 4. So use factor by grouping if that's the case. But like I mentioned earlier, definitely use Desmos too. So we'll go over Desmos in a second when we do our factoring problem. So here's a formula I'm going to want you to follow for these problems. We're going to identify our polynomial. We're going to use factoring or factoring by grouping. And then we're going to check our roots. And like I said, Desmos is the best and quickest way to check your roots. So here's our question. It reads, if a and b are the solutions to the equation x squared minus 5x plus 6 equals 0, what is the value of a squared plus b squared? So first, we're going to identify our polynomial. Here it is. So I'm going to use factoring on this one because we don't have a term in front of our x squared. And so I think x minus 3 and x minus 2 are going to be my factors. And I knew this because if you do minus 2 and minus 3, we get our negative 5x. And then if we multiply negative 2 and negative 3, it's going to give us a positive 6. And you can always check this by foiling out the equation that you factored to make sure it equals the equation that you started with. But this one I'm pretty confident about. And so from here, I can see that my roots are x minus 3 equals 0, so x equals 3, and x minus 2 equals 0, so x equals 2. So here are my two roots. And it's saying if the two solutions are A and B, and so these also equal A and B. Either one could be A and either one could be B. And lastly, what it's asking us is that what is A squared plus B squared? So A squared is going to be 3 squared plus B squared is going to be 2 squared. And that's going to give me 9 plus 4 or 13. 13. So that's the correct answer on this one. Now let's move to Desmos to make sure we're right. So now that we're in Desmos, I'm going to plug in our equation. So we have x squared minus 5x plus 6. So here I can zoom into where I see the roots are crossing. I can click on them. We have roots of 2 and 3. So this is what we found the old-fashioned way. But as you can see, I found it in Desmos in like 10 seconds. And then we just have to know that these are A and B in the context of our problem and plug them into that equation, a squared plus b squared, and that's going to give us our 13 again. So like I've mentioned a few times in this video, Desmos is a must for this concept, so make sure you're using it to its full extent because it's going to give you free points in this concept and is the most useful tool you have. So know how to factor by grouping in case you can't use Desmos for one of them, but make sure to use Desmos when you can. Good luck on these.